In the next section of lessons, we're going to be talking about time series objects. There are a handful of models I want to discuss, but most importantly, we need to know how to create XTS objects as well. So in this lesson, we're going to discuss how to create and manipulate an XTS object. XTS stands for Extensible Time Series, and there are many tools that help us deal with different problems we can come across when working with time series data. Previously, we have talked about different time classes, such as POSIX CT. So we can use the system time function to get the current system time. And the class of that object is POSIX CT. Now I want you to install a package called XTS using the install.packages function. And then we're going to load it into our environment using the require function. Now creating an XTS object is simple. It requires two arguments, a data vector and a time index. So why don't we create our first simple XTS object? It's going to be 20 random numbers, and we're going to set the order.by argument to be a vector of dates. When we use the class function on this XTS object, we get XTS. And we can also look at the attributes. When we look at the attributes of X, we're given a few things: the dimensions of that object, the timestamps, which are turned into numerics, and then there are other things such as time zone. Now we can also throw in hourly timestamps. Whenever we subtract or add integers to system time, it is in seconds. So I can multiply a range by 3600 to make sure that we are subtracting hours. So instead of system date, we're going to use system time. And I'm going to subtract 3600 times this range of numbers 20 through 1. And I'm going to set a new attribute this time called time zone. And generally, the format of time zone will say something like this: America/Chicago. Now let's talk about subsetting. There are ways to subset time series data by any time frame. We can take either a single day. So when I entered this one day as a character string into the square bracket subsetting notation, it returned only those observations which were from March 26th. We can also subset by using a backslash operator in the square brackets. And you can see with this notation, I'm going from this timestamp all the way to this timestamp. It should always be in that format. So let's talk about a couple of functions that are very helpful for XTS objects. The first is lag, which will lag the values. So if I lag X, for each observation, it's going to give me the previous observation of that data set. All of the observations get shifted forward. One timestamp is another way to think about it. That's why there is an NA at the start. There is no 0th index observation that it can pull from. Now we can set the number of lags using the K argument. So if I set K to be 5, we're going to get NAs for the first 5 observations. And then at this time, it's going to be able to pull whatever observation was 5 timestamps ago. You can even do negative lags. If we set K equal to -5, it's going to end with a bunch of NAs. Another useful function is diff. It returns a vector of the change between each observation. Now it's a little harder to see this because they're random variables. But for example, if I create an XTS object out of just the integers 1 through 20, and I did a diff on X, it's going to return a series of 1s with an NA at the start. In this lesson, we covered some of the basic ideas of an XTS object, such as how to create one, how to subset one, and a couple different functions that we will be using.